Corporate technological environments are iterating at a pace that breaks traditional planning cycles. What used to be a decade-long software transition now happens in quarters. To build an academic program capable of surviving this acceleration, we have to look exactly 5 years ahead and define a highly specific target: the 2031 business graduate. By the time current freshmen enter the workforce, they will be stepping into roles that have entirely new operational baselines. They will apply for positions like AI-enabled business analyst or digital operations manager. This diagram illustrates the technological ecosystem they must command on day one. Graduates will navigate predictive CRM features, forecasting client behavior, generative AI writing tools, ERP platforms, and complex business intelligence dashboards. Notice how the automated data flow between these hubs entirely replaces the manual spreadsheet analysis that defined entry-level business roles for the last 30 years. A typical Tuesday for this 2031 graduate involves evaluating supply chain risk alerts generated by machine learning and leading cross-functional meetings where algorithmic insights dictate the quarterly strategy. If this advanced, highly integrated profile is the baseline expectation for 2031, academic departments cannot afford to guess at their curriculum. They must immediately reverse engineer their current program structures to build this exact graduate. The structural problem we face is a matter of pacing. Higher education curriculum development cycles inherently lag behind corporate technological adoption. To solve this timing mismatch, the SVSU AI Task Force developed a specific methodology. It is called the Departmental Future Graduate Stress Test. This is a self-guided foresight tool. It forces academic departments to formally project workforce realities 5 years ahead, removing guesswork from the planning process. The tool functions by strictly auditing a program's current student learning outcomes, the formal, measurable goals of what a student should know by the end of a course, against this projected technological baseline. Using this methodology, departments transition from passively reacting to technology trends after they happen toward methodically projecting future workforce needs. The first phase of the stress test isolates where the machine ends and the human begins by defining the boundaries of automation within a specific discipline. In this flowchart, an automation wave absorbs routine tasks like data aggregation, projections, and reporting. This forces an evolution. Managers must become data-informed decision leaders. Market value shifts to strictly human-centric capabilities. Strategic decision-making, ethical judgment, and change management become the premium skills. This creates a critical new competency. Employees are no longer expected to generate insights manually. They are expected to critically interpret the insights generated by AI. In the finance sector, for example, analysts will spend their time supervising and validating automated forecasting tools instead of building quantitative models from scratch. Higher education departments now build value by teaching cross-functional leadership and ethical oversight of complex algorithms. Departments must take these evolving expectations and organize them into a structured, teachable hierarchy. This 3-tiered pyramid maps the required skill progression. The wide base layer represents the foundational requirement. Tier 1, AI literacy. Literacy ensures students understand core predictive concepts. They must recognize the technical limitations of algorithms and grasp the ethical implications of handing decision-making power to automated systems. Moving up the structure, we reach the operational layer. Tier 2, AI application. At this level, students actively use AI tools to solve business problems. They build live analytics dashboards, automate their own reporting workflows, and conduct sophisticated scenario modeling. Finally, the apex of the pyramid represents the strategic layer. Tier 3, AI adaptation. The baseline graduation mandate is strict. Every student in the department must achieve Tier 2 application. Meanwhile, students in highly technical concentrations, like management information systems or finance, must master Tier 3 to lead enterprise-wide digital adoption. Integrating this hierarchy often triggers a primary concern among faculty: the fear that embracing digital transformation requires abandoning foundational academic theory. This leads to the risk of overreaction. If a curriculum overemphasizes specific, rapidly changing vendor tools, it crowds out critical economic and management fundamentals that actually teach a student how to think. The opposing danger is the risk of inaction. Failing to integrate analytics weakens employer confidence in graduates, which ultimately drives down program enrollment. This diagram illustrates the necessary solution, the balanced strategy. AI is treated as a foundational layer woven into existing courses, maintaining perfect equilibrium with traditional theoretical elements. Executing this balance requires a rigorous course-level mapping audit to update existing student learning outcomes. Under this audit, introductory courses are updated to expose freshmen to basic AI-enabled business tools. Existing marketing courses modify their standard syllabi to integrate AI-driven customer segmentation exercises. Finance courses replace outdated manual spreadsheet exercises with AI-assisted forecasting labs, and operations courses implement predictive analytics platforms directly within their existing logistical simulation modules. Innovation stems from permanently embedding algorithmic literacy into the DNA of every existing subject. To prove these internal curriculum shifts are accurate, the stress test requires an external validation phase called light market research. Findings from regional employer interviews consistently highlight a singular demand. They need graduates who can interpret the outputs of advanced analytics, rather than spend their time performing manual calculations. Broad job scans confirm this. A text scanner extracts terms like data literacy, AI familiarity, and ERP proficiency, systems managing core processes. These keywords plot a massive upward trend. Even major accrediting associations like AACSB and SRHRM are aggressively pivoting towards ethical AI governance. These external market demands tie directly to the institutional stakes of university recruitment and student retention. University marketing materials must immediately pivot. They need to emphasize that the program produces AI-ready graduates with hands-on experience using modern business intelligence platforms. Failing the market validation test produces underprepared students and weakens program enrollment demand. The final, actionable output of the future graduate stress test is a structured, multi-year implementation plan to execute the overhaul. In this timeline, Year 1 pilots analytics modules and an AI and business course. Year 2 revises learning outcomes and updates capstones for AI analysis. By Year 3, the timeline completes a full curriculum refresh and formal audits with employer advisory boards. Running parallel to this timeline is the necessity of continuous faculty development, requiring professors to engage in analytics certification and AI governance seminars to support the transition. The requirement to prepare the 2031 graduate demands immediate, structured action today to fuse traditional business fundamentals with modern digital transformation leadership.